I can solve that precisely. Here we go. A little bit of distributive, you can handle that. I know what y is. It's 3. Am I finished?
You have to do it for the
What do I
x.
need to do now?
You have to do it for the x too.
Put that back in either one of the equations to find out what x is. You know, I need a point. I need an x and a y. So a y is a good start, but it doesn't tell me what the whole point is unless I put it back in and finish it off. Hey, this guy already says x equals 8 minus 2y, right? So since y is 3, x is 8 minus 2 times 3. It's 8 minus 6. X is 2. So there's my point of intersection, ladies and gentlemen. 2, 3. What my graph almost told me, if I'd drawn a little bit more accurately, this tells me precisely the point of intersection of these two lines is the point 2, 3.
Wait, Dr. Brice.
Yes.
What I don't do, like,
You have to talk at the end.
okay, like,
Get mad at that graph.
roar. Like, okay, where's the problem? Like, the 2x
Where's the problem?
Yeah, 2x minus y.
I'll give you two equations.
Okay.
Here's the problem right here.
Okay, I see.
I'll say solve the system of linear equations. In other words, where do they intersect?
So you just have to substitute in that.
Solve one of them for x or for y. Doesn't matter. In the other equation, substitute. That means you'll either solve for x or y, and once you get an x or y, you put it back in either equation to find out what the other variable is going to be.
Oh, okay, gotcha. Thank you.
Okay? Now, obviously, this works well when it's very natural or easy to solve one equation for x or y. That really helps, right? So if that looks to be the case, it might be a really good choice. Let me show you the other method, and then we'll work some that involve. Second method. This is substitution method. Second method is the cancellation method. And my objective is to cancel x or y terms. Now you know what things cancel. They're called opposites. -7 plus 7. 4y and a -4y. Things that look exactly alike except their signs are different. Those are opposites. That's what cancels. So, when you have a scenario like this, in which opposites are wonderfully obvious, everybody see the opposites? They're just sitting right, -3y, +3y, opposites. When opposites are wonderfully visible and accessible, hey, just add the two equations together. That's why this is sometimes called the addition method as well as the cancellation method. You just add the two equations together. So, step number 1, recognize or create opposites. Sometimes you'll have to create the opposites instead of just seeing them sitting there. And then secondly, add the two equations together. And notice what has to be true before you can add the equations together. Y'all see this? X's, Y's, equal sign, numbers, they're all lined up. Hey, if they're not all lined up, well, you line them up. You move stuff around so that everything is in order. All right? Now I'm ready to add stuff like terms. X and 5x, that's easy. These guys are out of here. They go to math heaven. This is negative math. All right. And see, that's the benefit of it. No more y's in this case. One variable, one equation, I can solve that. Divide both sides by 6. So x is negative 3 over 2 or negative 1.5. Take your choice. I'm sorry, what?
You don't have to go back and plug it in anymore?
Yes, you do. Because I don't just need an x, I need an x and a y, right? So take your choice, go to either of the equations, and substitute this for x. That looks pretty easy right there. X minus 3y. I'm going to substitute this for x. My numbers together. Negative 3y equals what? Negative 1.5. Okay. You may use your calculators when that presents itself. 5 both sides by negative 3. Y is 0.5. So here's my point. X is negative 1.5. Y is 0.5. So negative 1.5 and 1/2 is basically my point. If you want to stick with fractions, feel free. If you want to go with decimals, take your choice. Hey, notice the benefit of the cancellation method, or the hint that you might want to use the cancellation method. Got me some opposites. If the opposites are just sitting there staring at you, I definitely use the cancellation method. Just add the two equations together. Opposites are gone. You only have one variable left. How much time we got?
10 minutes.
10 minutes. That made a whole bunch. Got 10 minutes. All right. All right. All right, let's check this bad boy out. This is, no, you only got 2 methods. So this is another problem. And this is the way it's going to be presented to you. You're going to be given 2 equations like this, and the instructions will be solve the system of linear equations. And you're either going to say, hey, they're lined up nicely, there's some opposites, I think I'll add them together. Or you're going to say, I can solve one of these guys really nicely for x or y. I think I'll use the substitution method. Which one do you want to use?
Substitution.
Substitution method looks pretty good. First of all, the stuff isn't lined up nicely, is it? So what are you going to solve for what? Top one for y, okay. So this guy yields y equals 2x plus 3. Then what? Plugging in the other equation for y. Remember where I have a y, I'm going to put 2x plus 3 right there. 6x minus 3. Everybody see what we're doing? You always have parentheses there. Did I do that all right? Everywhere I got a y, I'm putting a 2x plus 3. So you're always going to have distributive. Minus 9. Okay there? 6x minus 6x, those guys cancel. And I get negative 9 equals...
That doesn't look good.
Wait a minute, is negative 9 equal to 3?
No.
I don't think so.
Not today.
What kind of statement would you say we just came up with? False. It is a false lie, ladies and gentlemen. This is a false statement. Notice no x's or y's are left. Just a universally false statement. Remember what we said whenever we solved an equation and we got a universally false statement? What was our conclusion? No solution. Okay, remember what we're talking about when we're solving for systems of linear equations. We're talking about their intersection. Everybody with me? We're looking for the intersection. If I get a false statement, what does that say about the intersection? They don't have an intersection. How is that possible? Early. You get a false statement that implies no intersection. The only way that's possible is I got myself some parallel lines.
So if there was a true statement, will they be the same thing?
Yep. That's my next problem. That's okay. But the answer is yes. Let's try this again. Last one. Once again, you will be presented with two equations. Anybody got a suggestion what to do to solve these guys? Which one do you want to solve for what?
Cancel it.
The first one for?
Right.
First one for x. Just think about it, ladies and gentlemen. You don't have to do anything except move one term over to solve for x on that first equation, right? Otherwise, every other variable, you got three other options, you're going to be dividing by something. That's no problem. It's just that all you got to do to solve this guy for x is move this 6 over. So x is 2y minus 6. That means everywhere in the other equation, I have an x. I'm going to substitute 2y minus 6. And it's going to look like that. A little distributed. Four y's cancel, and I get negative 12 equals negative 12. Notice, no x's, no y's. They're gone. I just get a completely true statement. Hey, negative 12 is equal to negative 12. That's absolutely true. What do you think is my conclusion there? The intersection is true for when x is all real numbers, in other words. I got the same line. They overlap. If I get an absolutely true statement with no x's or y's involved, I have myself